problem, isn't it? Because eventually the slogan really becomes drugs. And that's not at all what you really wanted. And so, and every one of us have been in the situation in our lives because you come up with this brilliant design idea and then you end up having problems in production. And then you're like, gosh, how did I end up from being praised for a great idea? Now everybody telling you that's the worst idea ever because that's not working in effect. So how can we really deal with it? So that's the whole point is we are really good at thinking. We are not really good at thinking through. And so how can we save our, you know, efforts in the thoughts we had and make sure it actually will work all the way into production and be valuable. And that's what I want to talk about today is things we can learn from our own experiences, but from experiences of others who we consider to be the experts and these amazing people in the history of our humankind. So let's talk a bit about a few things. Now, this is a theory I've had for quite a while. And my theory is those who design the bathrooms in a hotel have never showered. And I can prove this to you. And I'm in a hotel, I go into the bathroom and I say, do the people ever shower when they design these bathrooms? Because you get into the shower and you're like, how do I use this? I can't tell you how many bathrooms I've been in a hotel where I hit my hand every corner I turn. Or sometimes things don't work. They're too hot, too cold. I mean, everything possible. And you think you have covered everything. But this is a hotel in Montreal. I was there a couple of years ago. I'm not even exaggerating. I just had to take a photo. When you're angry, you don't shower anymore. You tweet about it. And so here's a photo I posted. This is literally the shower. Does anyone see what's missing here? Where do you put your soap? There was no place to put the soap. So I walk in with the soap, and now I'm spending 5 minutes designing how to really have a soap while I shower so the soap doesn't get all wet and soggy. And I'm trying to say, is this a puzzle maybe they built for me? Maybe this is not a showering activity, but an IQ test built into it, right? So I went down to the front of the front room and said, "Excuse me," and she's like, "Yeah." And I said, "The bathroom," and she's like, "Don't even talk about it." I said, "Seriously?" She's like, "Yeah." And so it's not just my room. It's like, no, the entire hotel. They forgot to put the soap, dish. I'm like, seriously? And this is one of the theories that I've developed over time. The people who use the software make the best software, hands down. If you're a user of a software, you make the best software. If you are developing software for somebody else to use, there's a complete disconnect because your focus is on coding, not on usability. And so, as an example, I have Rivian. Rivian is an amazing engineering. I love that electric vehicle. But a few months ago, I was complaining that when you get on the freeway, and most of the freeways I drive in, we can drive in at 75 miles an hour. That's right. I apologize for you. I did say miles an hour, not kilometers. We are still used to barbaric units. Unlike you civilized people who use better metric units, I don't even have a clue what that is in kilometers, so I apologize for that. And so I want to get on the freeway. I want to turn on the cruise control, and then it would put it on the speed at which I was. And then I got to keep pressing the button to go up in speed. And I was telling my son, this is kind of stupid. And then a few months later, there was a software update, and you get on the freeway, you press a button, and they realize what the speed limit is because they have the data, and they immediately speed up to that particular speed limit. And I was telling my son, hey, this is really cool. And he said, yeah, Dad, that's what happens when software developers actually use the product they are developing. Because that's a thought I had as well. And same thing, the people writing the code said, that's kind of stupid. We got to fix it. And that's the beauty of a person who can develop the code can actually fix it when they're a user as well. I think very few fields can actually do it. I don't think dentists can do that to themselves. I'm a dentist, right? That's not going to go end well. Maybe accountants, I don't know. But very few professions can actually fix the things they need. And that's the beauty of our field is if we are a user of a product, we can do better as well. So that's one thing I always complain about. The same thing, I love this room, by the way. I love this room. But I cannot tell you in how many conferences I'm in. They will place the screen so that nobody can see it. And what's the point? And everybody's like doing this to see the screen. So I also have a theory. Those who designed the rooms never actually learned anything. And that's true actually from what they produced. So this is something we want to think about. How can we really think about the consequences of what we design? I came across this very recently. There is this door I saw, and a great idea. When people work on different things, we want to think about what's the consequence of it. So here is a door, as you can see, and the design was very purposeful. When you open the door and enter the room, you want the door to shut automatically. So they have this little device that's going to close the door as soon as you step in. But the person who designed this did not communicate with the rest of the people. So as a result, it left a huge hole on the wall. And you're like, what just happened here, right? So clearly there was no communication. Clearly nobody thought through. And of course, when the person opened the door, there was a oops. And what do you do about it now? It's a little too late. So the point really is, again, thinking versus thinking through, we got to be careful about it. So that becomes very important. So the question then is, what is the consequence of what we design, what we create? As it turns out, what you don't know can actually hurt you. This is one of the problems we live in. It's the fear of the unknown. But it's not just the fear of the unknown, but the consequences of the unknown makes a big difference as well. This comes down to the story of Vasa. I was in Stockholm last year. I was walking through the museum in Stockholm, and they have this beautiful museum built around the ship called Vasa. This is not Vasa, this is a model of Vasa. And that beautiful ship was designed in the model. This is the model of the ship that was designed in the 1600s. And the ship was designed by one of the most renowned architects of that time, Hendrik Hybertson. And Hendrik Hybertson was considered to be the best architect in Sweden, in Europe at that time. The emperor of Sweden wanted to show his might. He wanted to show that he is the most powerful king. So he hires the well renowned architect and says, "You will build a ship that will scare the heck out of anybody in the world." And unfortunately, the architect did not know to say one thing. Remember the famous phrase, the emperor is not clothed. And the emperor said, "You will build the top deck and you'll put all these huge arteries on it." Well, guess what? Nobody really had done that ever before. There is one thing I've realized in life. If you ever disagree with physics, you know who's going to lose? Because physics always wins. And he said, "I want all of this on the top deck." And the architect tried to tell the king, "Excuse me, that would not work in law of physics. There's this thing called the center of gravity." And the king said, "I'm the center. You have a next question for me." So what do you do when the king says that? You just build what the king wants. And so they built it, and they put people on it, obviously. And it took its very first sail, and it drove 1,400 meters. You say, wait, you use the metric unit right now. Yes, that's because that I read it from the Sweden website. They use civilized units like you do. So that was 1,400 meters. It sailed, and that's all it did, and went right to the bottom. And that was in 1600. In 1960, they eventually developed the technology to pull it out, and they put it there for 17 years to cure it. And then they made a museum out of it. And about 160 people died on that day on that ship, which is extremely sad to know about it. And what's even worse is nobody was punished for this. Why? Because when the king makes the mistake, who do you punish it? So the point really is This is an example of when we do things when nobody has ever done before. So how many times have you seen this on software projects? Hey, we got to use this technology. Has anyone used it? No. Have you built microservices? No, but we love it. We don't know why we love it, but we want to build it. And we jump on it and we're infatuated about it. And the result is a disaster. And we are not, and it shrinks like this ship. So the point really is if nobody has ever done this before, why would you want to build it without knowing if it's feasible? So, is it feasible? Will this work? Have you built something to that scale? Have you built something to that performance? Have you built something that to that particular set of features? Is the team familiar with it? It doesn't matter if somebody else has done it, but has your team actually spent the time building it? And with this group of people, with this group of users. So, in other words, we have to really ask the question, so our products don't end up like Vasa, how can we really be, careful about it? This also brings up, I apologize for the things being cut off right there because of the resolution. So here is another example we can learn from. This was back in 1940s. They wanted to build a bridge across the Tacoma River, and they wanted to build a narrow bridge for auto to drive over. So this bridge project was started. They had never built a bridge like this before. And the people who were building the bridge at the time were so eager they got the contract. And they were a group. And of course, the problem is in a lot of these parts of the United States, you can have extremely high wind. I live in a place which I feel like I'm in a windstorm almost 90% of the time. You step out and you're like, ooh, what's going on here? And so there's a lot of wind, and you don't know when there will be a wind. And so there were people who were very curious about this particular project. And guess what they did? They built models of the bridge, and they turned on really high power wind tunnels on it. And then they blew on the bridge, and every single model fell apart. And they were like, excuse me, we built models, they're all falling apart. You guys are building a bridge. Do we want to think about it? And they were told, well, you don't understand math, do you? Well, the problem is their math was wrong, but they would refuse to even consider this. So they went ahead and built this particular bridge, and guess what happened? Let's take a quick look. I won't play the entire video here, but I want to just show you a couple of little things that you can see here in terms of what it's going to do. So let me just go back here and try this one more time. So let's try this one more time. So I want to show you a little example of what happens when we don't listen to things like this and we try to really build it, and what a disaster it could actually be, if you will. So looks like my internet connection wants to bail out. Let's try this one more time. So essentially, this bridge they took the time to build it. And of course, once they finished it, they inaugurated it, they celebrated it as one should. And once they finished it, it was used for traffic for a little while, but a total of 4 months is all this actually stood up. So oops, let me try this again. So it stood up for about 4 months in all, and unfortunately, that's all it could last in its lifetime. So let me try this again. So right there is the bridge being constructed. Let's take a look. And like I said, I won't play the entire video. So they had built it and they had inaugurated in May 1940. That's a construction you can see. They had, how the celebration of inauguration. That was fantastic. And then a few months later, the bridge started really swaying. And of course, when something is really broken, what do? You don't stay away from it, right? So there were people who were trying to walk on it because how cool that would be. And so you can see maybe a ghostly figure in the middle that this person is actually trying to walk. I apologize for the quality of that video. That's from decades ago, obviously. And of course, somebody tried to even drive a car on it, and there's a person walking on it, and that didn't go really well. And eventually, of course, because of the wind, it did not, stand, and it fell apart, one fine day, 4 months after it was built. Again, a lesson we can learn from quite a bit is, what does it mean to build something of that scale, of that magnitude? And there was one day when there was a lot of wind, and it just took its last, swaying. And of course, somebody was, measuring the time it is taking for that little oscillation, and they found it was a 5 second. So do the math. So that is again something for us to think about. How do we really build something of that scale? How do we sustain it? But of course, I always tell people I make a lot of mistakes. I want to absolutely convey that to you. I'm not trying to pretend that I'm actually good. I'm actually really bad. I make a lot of mistakes. And these people also made mistakes, but there's one difference in everything you see here. When they make a mistake, it ends up on the news. When I make a mistake, exactly three people know about it: my wife and my two children. So that is the scale again we are talking about here, right? So it's very unfair, I know. But when it ends up on the news, we all can learn from it. We can really relate to it. So this was an experience in France, and their railway system was very different a few years ago. The people who were responsible for the tracks was a different company than the company that was responsible for the trains. This is very unfamiliar to us, right? Because we all have one team that does everything, right? Our QA is, in-house. Our developers are in-house. We talk to the users every single day. Well, you know what I'm talking about, right? So they had the department that runs the railway tracks, very different from the departments that run their trains. So they ordered 2,000 trains, for new, beautiful trains. And when they built out all these trains and they brought the trains over, is when they found out that of the 2,000, of 8,700 train stations, think about this for a minute. Of 8,700 train stations, 1,300 train stations were too small to fit the train. Imagine you are the driver of the train. You are riding your train the first day, and you're looking at the platform, and you hit the brake, and you realize this train won't go into the station. And so they had to shave away the platforms to widen the platforms so the train can go in. That cost them a $68 million. Now imagine, oops, we only did not plan for that $68 million that we have to spend to break the platforms and widen it. So how could we make such a mistake? But to make things even more interesting, the French government covered this up. They didn't want anyone to know about it. Well, right, don't talk about it. Let's just expand these until a particular magazine journalist kind of went around and said, why are they shaving off these platforms in these different stations? And then this whole thing blew up. Again, to that magnitude, how could we fail so big? What did we do wrong? What if you had built one train and sent it around? What would you have discovered rather than building 2,000 trains? Something to learn from. Again, have we all written a lot of code and saying it'll work? And what do you ask the programmer? Are you sure it'll work? What do they tell you? I hope. I hope. That's called hope-driven development, right? Hope-driven development is amazing. I hope it's going to work. Very scientific, as you can see, right? And we just have a bucket of hopes every morning, and we just take it out a little bit more every day, make sure to refill it overnight. We got a lot of hope on it. Hope is great, but I think we need something more than hope. So that's something to think about. So what you don't know can really hurt. So when I write software, what I want to know very quickly is, what is it that I don't know? Because if I live with what I don't know, that's what is going to come and hit me in the back. And I want to know what I don't know. The sooner I know what I don't know. But how do you know what you don't know? You don't know that by talking about requirements over and over and over. You don't know that by just sitting around and talking about things to developers and users. When you start building things and when you start using things, you get to know the reality of things very quickly. So the faster you can get to it, the more feedback you actually end up really getting over time, so that can be really useful. So there are many unknowns that we constantly have to deal with. And our life as developers is really working with these unknowns every single day. Now, one of the things I often encourage my developers to say very boldly is, very boldly say, I don't know. We should be open to accept I don't know. We have this tendency sometimes, hey, maybe if I say I don't know, that's a reflection on me poorly. But I would say it's quite the opposite. Because if you say you don't know, you're opening it to going and finding what you need to know. And that really tells us we got more work to do. It brings more reality to what we are doing. So be open to say, I don't know. That's a good thing. So we want to think about these unknowns. So what are we creating? And software development is that business where we create things, but it's not like a predictive manufacturing where you're building one more of this product. When you're developing software, you're trying to understand the nuances of the software you're building. So there's a huge amount of unknown. And even if things are given to you, there are things you don't know. I'll give you an example of this. I was a consultant on a project where this company was rebuilding an existing product. So this was in the market. It's been around for 10 years. And the company said, it's old technology. We cannot support it anymore. We're going to rebuild it. So I'm the new consultant. I was not involved in the previous project. The team had developers who have been there for a while. And the president of the company was in the room. This was a very important project for them. And I was looking at requirements and I said, why does this requirement exist? And the immediate answer was, well, we need to implement this because it's a feature in the product. I said, well, thanks for that response. But why is this feature in the old product? And somebody said, that's a requirement. I said, why is that a requirement? And one guy rudely said, what part of that's a requirement don't you understand? And when people are like rude like that to you, how do you respond? And thankfully, I didn't have to. And the president of the company who was in the room said, hang on a second, answer the man properly. Why is that requirement there? Is there anyone in this room who can answer that question? And nobody could. You are implementing this because it's there in the old product. And I said, folks, I'm not trying to challenge you. I really don't understand why you would have this feature. And if you're going to take the time and money to implement it, I need to know why you're implementing it. And the president of the company walked to the front of the room and he said, how many people in this room know that we get 60% support call for that feature? And I was like, whoa, this was lucky to have landed on one thing that's such a mess. And he took a marker, put a little box around it, crossed it, and said, this will not be implemented. And it is to take the time, what are we creating? But I'm a mere mortal human being. I struggle to learn. I doubt myself a lot. So I want to ask, what do great people do? Do they walk on water? Maybe I'm the one who has trouble navigating this landscape. So I kind of looked up back into the history. What do the great people do? So there is this amazing painting, a renowned painting in Spain. And this was developed in 1659. And this is an extremely popular painting, Las Maneras, and they wanted to rebuild this. And Picasso said, hey, I'm going to recreate this painting. Of course, as we know, the style Picasso uses. And so he said, I'm going to recreate it. And you would say, well, it's Picasso. It's going to take him maybe one afternoon to paint this, right? So he can walk in, look at this and say, got it. I'm going to paint it. But Picasso wanted to do two things. He wanted to make sure he preserves the originality of that painting, but at the same time, he wanted to bring his own style into it as well. So guess what he did? He did not create his own masterpiece. Instead, he spent time creating over several years 58 versions of it. 58. How many times you write code and the next voice in your head is, am I done? Can I ship it? And he said, I'm going to create 58 versions of it. So he sat down for 4 years, created 58 different prototypes of it. He even spent the time creating a much focused version of just the master, icon in that painting. And these are all two of its 58 prototypes. In the museum in Barcelona, they got all the 58 along with the final masterpiece as well. If you visit Barcelona, make sure to go take a look at it. It's one of those rare where they never just kept the final product, but they kept the prototypes as well. So a lesson to learn is taking the time to take this time to create it. This was the final thing he created. This is what we often say, wow, but there were several things before that. So to me, the wow is not just this was created, but all the prototypes that was created along the way as well makes a huge difference too. To what scale are we trying to develop? And oftentimes we think about performance, we think about scalability, but what are we doing? Have we created something of this scale, of this performance before? That's a question we need to ask as well. And again, something we can learn from experiences. This is an amazing monument. I've been there maybe 3, if not 4 times. I do have to tell you, if you ever go to Mount Rushmore, I always look for things that excite everybody, but there are a few things that excite me as well. So if you go to Mount Rushmore, if you're driving on your way back, there's a very small tunnel. And as your car drives through the tunnel, I always slow down. Thankfully, there's not much traffic. And I would look through the rear view mirror in my car, and through the darkness of the tunnel, you see Mount Rushmore just at the distance. It's one of the most beautiful things ever I've seen in my life. So I just drive there just to see that little Mount Rushmore through the tunnel, if you will. But think of building something like Mount Rushmore. How do you build something like this? And guess what? You don't have much option for. Whoops. Because that's a mountain. You oops on it. You're not going to say, can we do a git rebase? Can we get this mountain back, please? We want to build again on it. So this is the funny thing in our field. Everyone else in the world dies to have the luxury we do. You commit, you rebase, and you move on. And yet, we are so reluctant to do it, right? Everybody else is like, can we undo this? They're like, no, you can undo a destruction you create on a mountain. So, as ironic to the word Rushmore, there was no rush in creating it. They did not rush through this. So, in creating this one, it turns out that the person, the architect behind it, started building prototypes. And when he started building prototypes, you can see one prototype there he is creating that's about his size, nothing really to the scale, obviously, to the big structure. And he was having the president's face in different directions. They had different clothing on them. So he had a lot of vision as to what they should look like. And then he built several of those prototypes. And this work went on from 1927 to 1941. That's a long time. He actually died in 1941 before this was completed. His son actually took the project and finished it that year. So this was a work he had done for a long time. And by building all these prototypes, he got a vision as to how it should really look like. And in the meantime, he examined the actual rock formation of where this is going to eventually get built. You can see this one, he's on a ladder. This is much bigger in size. And you can see this is getting closer to what was there eventually. But what he found out was that the rocks had cracks in them on the mountain. And the rocks were different in structure. So he couldn't build things the way he wanted to build them. So he had to redesign what he wanted to build. It doesn't matter what you wanted. The mountain tells you what you can have. That's the beauty of nature. The nature doesn't care what you want. You better want what the nature tells you that you can have, right? So as a result, he had to redesign his mountain, his monument to fit the mountain on which he wanted to build it. That's another example of what is needed is to keep prototyping it, to learn from it. That becomes really necessary. So we talked about knowing what we are building. We talked about scaling things to the level we want to scale. And every one of that is a concern we deal with every day in software. But a third thing we need to worry about oftentimes is what's your risk? Because risk is what separates the winning business from the losing business. Because a winning business handles the risk properly. The losing business couldn't recover from it. They're not resilient from it. So how do we deal with the risk? So I came across this as I was going through Switzerland last year, and they were telling me about a company that got into a contract. And the contract they ran into was they were required to build a network that ran 200 kilometers. Imagine that. I don't know what 200 kilometers is. You know that better than I do. If this was in miles, I can relate to it. But I'm going to say 200 kilometers is maybe half the distance between here and Chennai. Is that reasonable to say? So here to Mysore? Thank you for that. I appreciate it. So from here to Mysore, that helps us, right? So from here to Mysore, you want to build a network. And the requirement was that it needs to have a certain performance. And if that performance is not met, you are really in high risk of not meeting the SLA, and the contract penalties were extremely high. What would you do, so to use the word, if your lifeline depended on it? So they were struggling with it. How do we prove that this network performance is going to work for a 200 kilometers network? So they finally figured out there's only one way to really manage that risk. They brought in 200 kilometers of network into their office. And within their building, they built the entire network with coils, which I don't think I can even show to the magnitude how to achieve that. And they built coils upon coils upon coils within their office, and they made sure this was actually working before they rolled it into that 200 kilometers. So imagine one building where you got 200 kilometers of cable that you built. But if you really think about it, right, we often worry about things in software. But look at our friends in NASA and other space agencies. They're spending missions to places where humans have never, ever been before. And of course, we also know about Mars rover. They forgot that there's a difference between kilometers and miles, like the struggles I have. They're not any different from us, except their mistakes are well known than ours. So how do you know this is going to work? That becomes very important. And how can you really validate this as well becomes a concern. Now, I think we all complain about our lives. We complain about how terrible our job is. We talk about, oh my gosh, you know what happened when I had a memory leak. But there are people who do some work that just blows my mind. It humbles me. I can never stand in front of them and say, when they say what you do, I say, never mind. It doesn't matter in front of what they do in their professions. One such thing is Dr. Marshall. He is 72 years old now. I just will tell you this before we go further. He is well and alive. And this was back in the 1980s when he was in his 40s. Dr. Barry Marshall was interested in finding what caused ulcer, peptic ulcer. And at that time, I'm sure you have heard about this, right? And they were talking about what causes ulcer. He got eventually a Nobel Prize for this. But at that time, the prevailing belief was ulcer was caused by stress, spicy food, and too much acid. I got angry reading the word spicy food. That's what I live on, right? You can't take spicy food away from me. I'll live with ulcer, but no less spicy food. Scott knows about this very well, right? So essentially, the idea is this is what they believe. So they would say, you got ulcer, quit eating spicy food. I'm like, are you kidding me? That's not going to happen. Well, thanks to Dr. Marshall and Dr. Warren, they had a hunch. They thought, yeah, it's not the spicy food. It's actually a bacteria that is causing the ulcer. And everybody said, nonsense. Why? Because bacteria cannot grow because your stomach has acid. My argument is quite the opposite. Spicy food cannot do anything because there's acid. Spicy food is more acidic. So the point really is, his argument is, hey, it's bacteria. They said, there's acid in the stomach. Clearly, bacteria cannot do it. So, what do you do when the theory you have is opposed to the theory somebody else has? How do you prove this? He tried to experiment on pigs, logical, and that didn't work. So he was really desperate. So he wanted to prove this. So he went and got some funding for a year, and he decided to experiment. And he went to his lab technicians and said, take these bacteria, put them on acid, see if they grow. And they did 30 experiments, 30 of them. And every one of them failed. What do you do when 30 experiments fail? You're like, oh my gosh, yeah, thank you for that feedback. I love that music, the direction behind, right? Yeah, that's how dramatic it is, right? So, oh my gosh, what do you do when 30 experiments fail? Maybe these guys are correct that bacteria won't grow in acid. Well, it turned out the lab technicians, remember, they're there to do their work, and they were told, take the bacteria, put it in acid, turn the clock on, and they had a lab to maintain. So every 48 hours, they would clear the lab. They would start over the experiment. And so 30 experiments proved nothing. And the lab technicians thankfully got a little busy. They couldn't clear the lab on the Thursday. And they said, yeah, 30 of them failed. What good is it? Let's clean this up on Monday. So they just left it for the weekend. They came back on Monday. They was about to throw this away, and they looked at it and they said, whoa, notice what's there. There is bacteria. And the 31st experiment showed bacteria. And that's when they found out, unlike normal bacteria, this particular bacteria took more than 48 hours to grow. And the lab experiments never gave them more than 48 hours, so they could never prove it. And since then, they did 100 experiments total, and all but the 30 gave results the bacteria was growing. And so, guess what they did? They published this on a paper and said, ta-da, look at this. The bacteria does grow, it just takes more time, and so that's what is causing your ulcer. And the medical journalist reviewing the paper said, nonsense. We won't accept it. It's got to be the spice. Acid, it cannot grow. So he was sitting there thinking, how in the world do I make people realize this is what causing the problem? I'm not recommending this you do. I don't recommend this to anyone. But this to me is amazing to think about it. He realized the only way to prove it is to self-ingest the bacteria on himself. Really scary thought, isn't it? He took bacteria, and 3 days went by, and his wife said, you smell funny. And his wife found out he was sick. And that's when he proved to the world that ulcer was being created by this bacteria. He had ulcer for himself. And they eventually had to cure him. And of course, he's got other things that went on fine for him. What an amazing, amazing way to prove that things actually work. And then you go to your programmer and say, can we do a prototype on? I don't have time for it. Seriously? Think about that for a minute. So he self-injected this bacteria, and his wife noticed he was sick, and they found it. So is it feasible? Can we actually do this? So I will relate to this with my own experience. This was 30 years ago to the date, almost. This was one of my very first programming jobs, 30 years ago. And when you're a very young programmer, you haven't ever written production code, you're sitting there and working. What do? You feel like you can do anything and everything, isn't it? Because when you know the least, you have the most confidence. So at that time, we were using an object-oriented database called Versant. And I remember this was Versant 4.0. They had just implemented into this object-oriented database what's called optimistic locking. Well, it's optimistic locking. And they said, do you want to use it? How could you not be optimistic using optimistic locking? I said, yes, I know how it works. I've been through that training. I've read it. I can do it. So I implemented optimistic locking on my application. Remember, this is the first time the database has optimistic locking. Nobody in the world has used it. I was one of the very first person to apply it on a large scale project. And we finished development. I made so many code changes, and I was very naive, green behind my ears. And now, 2 days later, one of my team members comes and says, did you notice we lost some data? Oh, maybe there's a mistake in the code. We spent a week finding what the problem was. We couldn't find anything. We took a version of the code which did not do optimistic locking. We ran it. It worked fine for the same example. The version optimistic locking doesn't work. So what do you do now? Imagine this. You're a programmer who is relatively new. You got a code base where, oh, by the way, I forgot to tell you, we had 7,000 C++ classes in this application. So I'm sitting with this large code base in front of me, and the only person who has implemented this code is this guy, little guy. And my boss comes to me and says, so how's it going? I'm trying everything I can. I don't know seriously, I don't know what's going on. And what is the worst thing you want to hear when things are not going well? Your boss telling you, I know if anyone can do this, you can. Like, stop, leave, go away, right? And my boss is like, I know you're really good. Please stop that. I could not figure out what was going on. A month struggling with it. And I'm calling the database vendor. Verson folks, can you help me? They said, no problem. Send us your code. Which code? I've got 7,000 C++ classes. Before it can leave this building, 7 attorneys have to talk about it. I got to get permission from them to release this code out of the building. It's not going to happen. It's proprietary. So what do you do? And I learned my lesson the hard way. Oh, by the way, eventually found out what the problem was. It didn't work. They issued 4.1, which said bug fix for optimistic locking. I'm like, what? I put the bug fix, my original code actually worked. I did nothing except crying for a month because there was nothing I could do to fix the problem because it was not my problem. But what was the problem? I didn't know it was not my problem. I learned my lesson the hard way. I said to myself, Venkat, grow up. This is not the way to develop software. Fast forward 10 years later. What is experience, right? So that is the beauty of being experienced, isn't it? So I was on a project when the client said, you will build this product with this UI toolkit, which I've never ever heard of in my life. I don't know what this toolkit is. I said, this toolkit, oh yes, you need to use it. Are you sure? Absolutely. If you cannot use it, let us know. We'll find somebody else to do it. That was the conversation I had. I'm like, oh my gosh. Then I did a little convincing them. I said, I want to succeed on this project. So do you. So I promise you, let's build it with the toolkit I know, clearly mentioning in the contract. I will spend all the time and money converting the code to the newer toolkit. The minute I get access to it, learn it and apply it. They said, only if you promise to do it, written in the contract. So we started building application. But what happened in the meantime? I built their trust. Because every week I was sending them the product for them to use. We're finding bugs on their end using this tool already. So they were like, this guy is actually doing stuff. We have confidence in what he does. And I got the product, learned it, and I said, let me integrate it. I'm like, do you remember the last time you did something like that? Heck no. So I left the project, went to a separate, completely different directory, recreated a little example that mimicked that particular part of the UI. Our UI was drawing literally tens of thousands of things on the screen. I just created a hello world equivalent of 10,000 things on the screen to display. And my application written, real code written using the toolkit I know, was blazing fast. this little prototype with nothing else. All that you do is you fire it up. It's just drawing stuff on the screen. And you can sit there and watch it. Oh, there's one, there's one, there's one. I'm like, I'm doing something wrong. I spent 3 days debugging. Didn't work. So I called the vendor and said, excuse me, can you do me a favor? I'm using your product. It's not working. Clearly, I am doing something, really bad. I need your help to look at the code, and in 5 minutes, you can tell me I'm stupid. But I just want to know from you that I'm stupid, just to reconfirm that I'm actually stupid. Oh, we'll be glad to tell you you're stupid. Send it to us. So I sent it to them, and they called me within 2 hours. And they said, you're stupid. I said, yes, I know it. And I said, what was wrong? And they said, using our product. I said, what? And they said, why are you using our product? I said, what do you mean? Don't you want your product to be used? And they said, not like this. This is not the intended use case at all. This is not what you're supposed to do with it. Who gave you this bright idea? I said, can you do me a favor? Can you put that in the email? Tell me I'm stupid. They said, we love doing that. So they sent me an email. You're stupid for using this. Thank you. I went to my clients and said, hey, folks, I just want to talk to you about this. I'm going to make the port next week. But I want to guarantee you one thing. It's a one-way port. I'm going to port it once. I'm not going to report it. But before I port it, I just want you to look at this demo. And I want you to look at this email from the company. But it's a contractual agreement, architectural requirement. Just want you to know it. They call me on the phone. Stop. What are you doing? Well, I need to port this over to this because that's what the contract says. Are you kidding me? We don't want that performance. Hey, but you said you have to use the tool. Oh, we don't care about the tool. We just care about the performance. Then why did you tell me you have to use the tool? Oh, we don't even know what the tool is. Somebody said it's a great one, so we decided to use it. I'm like, oh, that's how you do architectural decisions. Thank you. I learned another lesson. So the point is, when you've never done something, just don't do it. It makes no sense. That's what I learned the hard way, and this really rescued me. So the code always does what you type rather than what you meant. But what did we mean? We sometimes don't even know that. We need to understand that over time and figure it out. So I go to developers and I tell them, let's do test-driven development. They kind of look at me like, what? I tell the same developers, let's implement code. Boom, the code is done. The same brilliant programmers, I say, write test before you write code. They're like, are you out of your mind? How do you write code before writing, how do you write test before writing code? And I was kind of puzzled by it. Why do these brilliant programmers who can write really good code have trouble writing test? And it finally dawned on me, there's a reason for it. We all do programming, but how do you write programming? Do you ever go to your desk and say, I'm going to write this code, and then you just sit there, type the code, and it works? Does that happen to you? Never, right? You write some code, and you're like, huh? You look up Stack Overflow. That doesn't help you. Does Copilot help you? ChatGPT help you? Sometimes it makes things worse. You call your colleague, they give you 7 opinions now. You're more confused. And you're like, I don't know what's going on with this code. And eventually, it seems to work. And you quietly leave it and step away, right? It's like, don't touch it. I want to go home, right? What do we call this? Programming, right? If others know what programming is, they will never trust us to do this. But this is our little secret in this room, right? That's what we do for a living. So programming, what is it then, really? Programming is a series of mini experiments that lead us to discoveries that help us to transition from a set of unknowns to a set of knowns. That's what we do. What is programming? Programming is not typing the code. Programming is to understand what the freaking problem is. Because I don't even know what I'm doing until I start doing it. And I'm like, whoa, that's what we were supposed to implement. Because when you start writing code, something funny happens. You can run it. When you run it, you can complain about it. And now you can start changing it. So when I tell programmers, write test before I write code, they're like, are you kidding me? I don't even know what I'm trying to write the code for. So what do you do? So here's the lesson I learned. If I know what I'm doing, I write test and write code. A lot of times I don't. So I leave my code alone. I go create a very separate prototype. I play with it. I learn how it works. And then I say, cool. Never tell anyone you wrote a prototype because if they find out, they turn your prototype into product without any test. So never tell them that. Be quiet. Don't say that that works. And if you have worried, delete it. Print a copy of it on paper and delete it. So at least somebody has to type it back if they have to, right? And then come back to your code base. Now you know a lot more about this problem. Write test, write code, write test, write code. So the idea really is learn to prototype so you can prototype to learn. It takes a certain amount of skill to start prototyping too. But first, learn to prototype and then prototype so you can learn how things actually work. So that gives you the confidence to be able to come and write the test cases as you move along. So we feel like we got one shot at writing the code oftentimes, and that is very misguided. That's not what Picasso did. That's not what the person who built Rushmore did. That's not what anybody who ever does anything of value do. They don't do it once and walk away. Why should we then? We should develop the sense, the discipline, and the culture to know that we got to experiment. We got to create things. So essentially, we often compel ourselves to get it right on the first write. But that is naive. That is illogical. And we should change the culture that drives us towards doing that. It doesn't make sense to drive ourselves to what is impossible. So we often hear about things like FOMO, but there's something else that we often that afflict programmers. It is the fear of, or maybe it's rather a reluctance to try things out. But that's a culture we want to change. So take the time to try things out. We need to experiment. We need to prototype a lot more than we allow ourselves to do. You don't need permission from others to do it. It's a permission you give to yourself for you to be able to do it. You need to empower yourself to do it. So experiment or prototype to learn, to understand, to isolate the issues from the surroundings, to validate, and to reduce the risk as well. And these are the reasons and more that we need to really take the time to experiment, take the time to prototype. An experiment either confirms your assertions or it clarifies your understanding. But in both cases, you come out winning. There is no loss here. Either you know more or you know that you knew more. And in both cases, you come out winning. So let's get out there and win and succeed doing it. And I hope that was useful. Thank you so much.
Thank you so much for that, Venkat. It was absolutely fantastic. All right, we would like to invite you to showcase your summit experience and win some lovely prizes by getting involved in our social media contest. All you need to do is follow at Developer Summit on X, Twitter, and LinkedIn to stay connected. Share your summit highlights, insights, and photos using the hashtag Gids, GIDS, and hashtag Developer Summit. You can check out the contest details in your copy of the printed summit guide. So let's spread the excitement and make your participation completely unforgettable. While we set up for the next talk, I meant to remind you that you can refer to your summit guide for the full schedule. We have allotted that 10-minute break in between each session so that way you have enough time to be able to move between your sessions.
Whenever you want.
All right, so for our next keynote, we have Ignacio Risco, who is the Senior Director at Red Hat. He leads all developer outreach programs, content, and initiatives. So please help me welcome Ignacio.
Thank you so much. Thank you. My name is Ignacio. Welcome, everyone. And after Venkat, it's going to be difficult to beat it, but let's talk about some code. With me, I have Ranky, also that is going to help me in order to do some codes and testing. So let's go through. And by the way, I'm going to talk about things or concepts that Venkat mentioned about, but I am going to put two things together. The first one is going to be about open source, and then the connection with artificial intelligence. So what do I do? It's very simple. I do basically understand the code behind the products that we produce at Red Hat, and we target or we talk to mainly developers, people writing code, but also platform engineers. We call platform engineers developers. These are the people that need to create the code that developers will use in order to run their own code. So probably you know that Red Hat is known as the best contributor in terms of contributions into open source. So we see a lot of open source, and definitely what we do with our products is we take open source ideas, a bit of what Venkat was talking about. We have a number of people creating open source communities, and then what we do is we take those pieces of code and we create our own versions, enterprise grade of the code that those open source communities are bringing up, and then we offer that code also to the community. So what is the connection between that and AI? We see a lot of similarities because in AI, what we find now is that there are also a lot of open source projects that they are starting. In fact, it's a complete mess. I will go through that mess today in order to understand, okay, what are the pieces of mess that we have today and how we can start using those messy pieces in order to start creating our own products. What is the connection between those two things? And by the way, if you think that you are not going to be impacted, think twice. Okay, today maybe you are not using artificial intelligence in your projects, but definitely Gartner believes that 80% of the projects, 80% of the applications that are running today will use some kind of AI. Think about maybe you write applications for hospitals. Think about all that knowledge that is running already in the hospital, how you are going to infuse that knowledge into your own applications. So there are several things that we need to talk through and how we can help you. First, we believe that AI is going to be hybrid cloud. Why? For several reasons. The first one is because you are going to train a model and you don't know where are you training the model and where you are going to use the model. Not only that, IDC estimate that 93% of the companies are already using multiple infrastructure clouds. In fact, you think about all the artificial intelligence that we are going to incorporate, all the data that is going to come from the edge devices, and you will need to use your device into public and private clouds. So the first element is you need to be sure that whatever you prepare, it's going to run around different clouds. Second, you need an OS. For that, 90% of the Linux already are using public cloud workloads. So Red Hat Enterprise Linux is our version of Linux that is enterprise grade in order to run your OS. Then the next step is where are you going to run your apps? And we believe that Kubernetes is the platform, the open source platform that is going to run your apps. In fact, I was at KubeCon in Paris a month ago, and at the keynote, Priyanka, the CEO of the CNCF, mentioned that AI is running over Kubernetes. So we believe that Kubernetes is going to be the platform, the open source platform that is going to run all the artificial intelligence models. What we have is OpenShift. And here, OpenShift, what we do is we run OpenShift on top of Linux, and then you have different layers. Depending if you need to use Kubernetes and cluster services, you just use Kubernetes engine. Then if you need to use DevOps services, then you have container platform. And then on top of that, if you need to do advanced management, then you have OpenShift Platform Plus. And all of these you can run across different clouds. So the key question is, you start with open source projects, you run hybrid cloud, you run Linux, you run a platform. But the question is how you infuse artificial intelligence. let's go through that, and we have a new element that you need to start thinking about. Who are those data engineers, data scientists, and ML engineers, and how we are going to start working with them? Well, everyone have a role. The data engineer is going to prepare and gather the data. Then the data scientists are going to deliver the models. And then the app developer are going to incorporate these models into their applications. And then the IT operations are going to ensure that everything runs. So we open what we call the open source AI new stack. And again, what Venkat was talking about, maybe some of you knows about Linux. Some of you maybe knows about Docker. Some of you even maybe knows about Podman. Some of you will know how to modernize Java applications using Quarkus. Some of you will know about Tecto Argo, but definitely will be very rare that all of you knows about all the different projects, open source projects running across the different stacks. And definitely the layer, the top part of that layer, it's what probably most of you don't know. Unless you are a data scientist and you are starting to work already with PyTorch, using or creating Jupyter notebooks and doing your experimentation and model life cycle with Kubeflow, probably you don't know those layers. But you need to know in order to incorporate, because the layers below are normally what we know about creating the apps. The layers above are normally what they need to know, data scientists, in order to create the AI. So let's see that in action. In the next minutes, Cranky will show how we are going to create an app that is going to incorporate AI. What we are going to see is some images. We are going to feed the model with certain images. In this case, it's going to be a dog, a red hat dog. We are going to incorporate that through Hugging Face. Then we are going to use Stable Diffusion. That is one of the models that we are taking out of Hugging Face. We will incorporate that in our Jupyter notebook. And then we will do the model fine-tuning for doing the testing, incorporating that in the app in order to have the application consuming the model. So let's see in action.
Am I audible?
Yeah, you can probably speak here.
Am I?
Yeah.
Um, so one of the ways in which most of the customers whom we've been speaking to, and most of the over the last 1 year, everybody has been working with some kind of large language models. How many of you have tried out some kind of a large language model over the last 1 year? And how many of you have taken it to production? Very few. So this has been one of the major problems. One of the major problems is there's a hype cycle. Many people are working with a lot of large language proprietary models. But then, if you've been taking a close look at what has been released, is there's the open source AI models which are coming out very fast, very rapidly, and they're closing the gap with these large proprietary models. And how many of you are experimenting with any of the open source large language models within your organization? Yeah, quite a bit. So this is something which is going to happen rapidly, and I saw this hype curve where even airline magazines are speaking about how generative AI is taking over jobs and software engineering roles and many other roles. Definitely there's a hype cycle, but it's the same way in which we have seen. It's not the most exciting of the technologies which the enterprises pay. It's the exciting technologies which can be catered to enterprises, and also the most boring of the open source projects are the ones which actually people pay for, right? So what's going to happen over the next few months, or few years, is a lot of open source projects are going to come, and you're going to experiment with many of these open source projects. So what we've done with OpenShift AI is we have created an enterprise MLOps platform where you can work with your data scientists, ML engineers, along with your application developers, onboard them together and work on your projects and deliver the projects across multi-cloud and also across a private and a public cloud in a true hybrid setup, right? So in this particular project, what I'll be showing is we'll be taking one of the stable diffusion models out of Hugging Face. We'll train it with our own data. So we want to generate a picture of a dog wearing a red hat, and then we'll try to serve it. So if you take a look at how many of you heard of OpenShift? Uh, cool. That's great. So OpenShift is a Kubernetes enterprise Kubernetes application platform. It's more like a platform as a service, which you can use for which you can use for making hybrid Kubernetes deployments, and it's the largest used Kubernetes distribution on private clouds. So what we've done is we got this constant requirement saying that, hey, our developers understand the Kubernetes, our developers understand how to do cloud native or Kubernetes native applications, but we want to implement AI within our projects. So this is where what we started doing is we started like Red Hat. Most all these projects are open source. So you have this project called Open Data Hub. You can run it on your own Kubernetes clusters also. So what this one does is um, you get the best of the open source projects where you can build your own data pipeline, you can do your data engineering, model experimenting, and also model serving. So if you go to the dashboard of OpenShift AI, you can click OpenShift AI and just one operator with your existing OpenShift cluster, or you could configure the Kubernetes operator pattern onto for Open Data Hub in order to get this running. Uh, Sorry about the resolution. There are certain services which you get out of the box. By far one of the most popular one with data scientists and ML engineers is Jupyter Notebook, but there are quite a few there are quite a few self-managed or partner serviced applications out here. So this is how the dashboard of OpenShift AI is broken down into. So if you take a look at it, you have the workbenches, you have cluster storage, data connection pipeline, and model service. So workbenches is where you really start working with your projects. Where in this particular cluster, we have enabled a Jupyter notebook, and this is the one which is going where your data scientists are going to work together and serve together. So in a single click, it's going to take from your code. So we use Backstage in order to onboard both the developers and the data scientists working on the same projects onto the same clusters or even external clusters. So we use Backstage as an onboarding tool for onboarding the developers within your team and the data scientists. And then once it's there, Backstage creates the code repos, and also you can mention what kind of models you want to work with within a single template, and you get the whole setup. And this setup is you're going to deploy your models as Kubernetes pods serving on the Kubernetes clusters. So so what we've done for this particular experiment is we have created a PyTorch model, and it's going to run out of Jupyter Notebook, and all of this is created with a Backstage template. How many of you are using Backstage within your organization? It's a very good project. It enhances developer productivity and also data science. So what you can do over there is you can configure everything, like say your what kind of data models you want to work with, and I think, and then you can just click it, and out of here, out of the box, it's going to take you to the Backstage environment, environment which is provisioned with Backstage. Here we have a Jupyter Hub notebook. So the first thing you want to check while running this project is you want to see if your GPUs are enabled, and then what we're going to do is we're going to use the Hugging Face diffuser model and one of the Google's boosting model in order to accelerate image generation, right? So what we've done is we are going to load a pre-trained model. Think of it as you want to experiment with your code bases with new open source models. You just get the models onto your notebook, and then you run it from there. So what we've done is we're going to do some configuration checks, check if some kind of application is running and the CUDA servers are there and your GPUs are there for your project. And then on, you want to like say, for example, generate a image of a dog. Right, so you're going to train a model which we have got out of Hugging Face, and this one could be the same thing. You could experiment with Olama. You could also experiment with any of the things. So, but I want to train it with this particular data. This is a dog which is wearing a red hat. So what's going to happen is, but it's not the dog which I want to train this data on. So, so what you have to do is you need to give your model certain pictures of what kind of data you want to train it on. So this is something you're going to work with. So again, you're going to check your GPU recommendations, and then you're going to start uploading the images of your dog back to the stable diffusion model. And again, you're going to do some configurations and all of this. So here, what you're doing is you're kind of you're uploading your images, training it against a stable diffusion model, and then you're going to connect your object stores and data stores onto the cluster. So what you're going to do, if you take a look at here, we are going to give the instance images of our particular model back to the stable diffusion model, and we are going to use one of the Google's Dream Booth technique in order to train the model. So this is something what we would be doing. But while doing like this data, it might take about 20 minutes for us to train the model. What you can also do over here is if you have complicated steps for your model, you could also create a pipeline of what you want to do. And like say, download the data, fine tune the model, and export the model into one of the popular formats. Like we are going to do it in ONNX format, but you can export the model into various formats. All you have to do is do a pipeline run. Once you start this pipeline, so this one runs a model serving pipeline with Kubeflow and also with Tecton in the backend for the continuous delivery of these models. Um, so we can check over there, but what we can do is we can also check one of the previously deployed model over here. So what it's doing is it's going to download your data, fine tune the data, generate the samples, upload the images, and also export it to ONNX format and upload it back. So once you have trained the data, you want this one to serve continuously. So the case serve is also built in into OpenShift AI, where you can create where you can deploy your models and also connect your applications with, like say gRPC, in order to deploy this model. So what we've done is once we've created the model, you can serve your model where you can open your pod routes to connect to the model's API interface, and then you can get your application running. So this is one of the sample applications where we have created, and we want to take our image Teddy and give it some place where it needs to be. So it's like um, so basically, we're training a model of this image. We are running a pipeline, and this pipeline has already been deployed. If you want to see how we do it in depth, you can come down to the Red Hat booth, and we also have a dedicated talk on OpenShift AI. So what we are basically doing is we are going to take models from any of the open source repositories of models, train those models, and then deploy them and serve them to any public cloud or private cloud, or even to external clusters from your development centers. So this is how it's one of the use cases where you can use, but there are quite a few use cases which you can use for credit card fraud detection or various things. Thank you.
So can you put the presentation again? Perfect. Yeah. And just to close, this is just the intro. We have prepared around 10 sessions in order to go deeper in all the technologies that we have been going through. Please look at the calendar to attend whatever you consider more relevant. And finally, we are going to be there at the booth in order to show all the different technologies that we have been through. Please, the QR code is also to become a member of the Developer Red Hat program. Thank you so much.
Thank you so much, Ignacio and Ramki, for that wonderful presentation. Next up, we have Mr. Jim Weber, Neo4j's chief scientist and co-author of several books. Everybody, please help me welcome Jim Weber to the stage.
We have to the resolution.
Okay, you want the res. Okay.
This forward, back,
Yeah, it's
and later.
okay. That's better.
Forward and back and later.
Super. Thank you. All right. Better late than never. That just shows that it's a real computer scientist or real software engineer doing the talk, right? Hardware problems. Hello, lovely people. It has been over a decade since I last stood here, terrified, in front of such an august and amazing audience. It's lovely to be back in town, lovely to be back here at the Great International Developer Summit. So I'm Jim. I work at Neo4j, the graph database company. Not going to talk too much about graph databases this morning. Plenty of talks about graph databases throughout the conference. I'll be talking about graph databases and Gen AI tomorrow. Today, I want to talk about distributed systems. Who loves distributed systems? Who hates distributed systems? You're both right. Yeah? Distributed systems are wonderful and terrible, and I'm going to teach you everything I know about distributed systems in 15 minutes. But first, let me tell you a personal story. So I am a working class Englishman. I am the first person in my family to get any school qualifications in the whole of my ancestry. And I'm the first person in my family to go to university and get an undergraduate degree. I'm the first and currently only person in my whole family to have a PhD. Now, you may be wondering what that was genuinely surprising. Thank you. That's not the point I'm going to make. The point is that my mum is terribly proud of, no, I misspoke. My mum was terribly proud of me because our Jimmy, she always uses the diminutive on me, our Jimmy,
I don't get Dr. Weber from her, our Jimmy, always. Our Jimmy has got a PhD and she's very proud. She can brag to the neighbors. So she asked me, our Jimmy, what is it that you do? I said, well, Mum, I work on something called consensus. And she says, what's that? Well, I'm like, it's quite complicated, but basically, and you can see the expectation in her face that I'm going to say something profound. Like if one computer, say, thinks of a number, let's say 10, expectation. And then another computer, I make sure it also thinks of the number 10 and stores that. Oh, that was damning. She said, the way she said, oh, that was hurtful, right? And I get it, right? Because it sounds so easy. You've got a few computers and they all just have to store the same thing, right? And it seems so easy, but it's not easy, right? Because things go wrong. And when things go wrong, it doesn't prevent other things from going wrong. And while you're putting right the things that have gone wrong, other things can still go wrong. Right? That's what makes consensus such an interesting problem. The world is full of entropy. The world is a garbage fire, and we have to, in small quanta, make good progress while the wind's in our favor. So I'm going to teach you about something called Raft. Raft is a wonderful, humane protocol. Raft actually comes from this idea of keeping logs tied together. So of course, underneath most databases, there is a log, which you can think of as a fancy linked list. And if you can tie those logs together, you can keep them in sync so that two or more databases can stay synchronized. And the wonderful thing about Raft, the people that built it was John Oosterhout, the guy that wrote Tickle. If you're sufficiently old, I'm looking for the greybeards to nod along to this. Not as much nodding, one greybeard nodding along, and you've had a shave. So it's not even bearded greybeard. John Oosterhout is wonderful. He's a polyglot, mathematician, computer scientist, awesome person. And he has this idea, along with Diego Ongaro, the distributed consensus protocols, things like Paxos. Who's heard of Paxos? Who understands Paxos? You're lying. Nobody understands Paxos, even the people that created it. It's too hard. We used to have Paxos in Neo4j at the time. We had about 20 engineers who had worked on it. I had about 21 opinions on how it worked, right? Raft doesn't do that. Raft just says simplify everything, because in distributed systems, complexity is where the bugs lie. And in distributed systems, bugs are subtle and complex and catastrophic. So it's better to have a less optimized system that's simple than an optimized system that's hard, because the optimized system is simply more risky. So I'm sorry to the very brainy people that built and understand Paxos, but you did it wrong. Raft, on the other hand, is very easy. Has this idea that we keep logs together. So here's an animation of Raft. And what's going on is that one of the servers in this cluster gets elected as the leader. And its job is to suggest to the followers, hey, would you like to append this value at this index in your log? Having reached the basis that we've previously appended the same thing at similar indexes. And so that's all it does. It's effectively saying, can you append this? Yes, I can. And if enough of a majority of the servers say, yes, I can append, then the leader can say, okay, enough people agree, let's commit. And this applies not only to the data that you'd like to store, but it also applies to the topology of the cluster. So you've got everything you need written down in a majority of the logs. So it's a safe, fault-tolerant system, and it means that even if the leader fails, as it does in this animation, someone else that has an equivalent log can pick up and continue processing. So it's a non-blocking consensus protocol that ties these logs together. And it's lovely. Honestly, you could read the short paper in that this evening and it will delight you. And it has some really nice properties. So it keeps logs tied together, keeps cluster membership and data together. Everything's simple. Raft decisions are always made by a simple majority. Now, the clever computer scientists will tell you, you don't need majorities for quorums. You can do things like trees and rows and all sorts of clever stuff to mean that a minority of deciders can make a decision. But by God, when there's a failure, unpicking that mess is horrible. And Raft just says, no, do the simple thing. If a majority wants X, X it is. Simple to recover from. So anyone can call an election. And ultimately, elections are decided by who has the most up-to-date log in the current era, in the current clock tick. And if two or more servers are equally valid as the leader, you'll toss a coin to determine who it is. And so this goes on. Note that in the logs that you saw earlier, there is both appended and committed. And entries, data that's being appended, is at risk. It may be truncated, but data that is committed into the logs is committed in a majority, and it will never change. It's immutable forever. So it's a really nice thing to recover from, because remember, distributed systems are a garbage file. Yeah. And you didn't get taught that at university, did you? The guy with the arm patches and the tweed didn't tell you that distributed systems are a garbage file, but they are. So how does it work? You effectively, as I said, you move from appended to committed to applied. But can you reason about consistency? Here's an app that you've just built. And as a user, it says I need to log in to continue my purchase. So I log in. Or I need to create a username and password, so I can do that. So I'll create my username and password in order to continue my purchase. No account found. Wait, what just happened there? It's an awful workflow for a user. What happened there? I'll tell you what happened there, eventual consistency. I created an account, it got stuck on one replica, it hasn't yet replicated to the next replica. When I go to log in, I happen to hit that replica and things go to crap. This is terrible. You've just lost a customer. So what do you good folks do? Thread.sleep 1000, right? You evil bastards. Never do that, right? That's terrible. So, and the thing that you need to know about this, in all distributed systems, because of this thing called FLP by Fisher, Lynch, and Patterson, hence FLP. Who knows CAP theorem? Who's ever heard of that? Lots of arguments about that about a decade ago. This is older and better magic than CAP theorem. This basically tells you that distributed systems do not work. But there is a window of time where computers just manage to hold their shit together for long enough that you can get some useful work out of them. But in general, distributed systems don't work, and that's proven in this paper. There's always a trade-off between availability and reliability. To make things available, you have to trade off reliability. To make things reliable, you have to trade off availability. That's the underpinning fact that underpins our entire discipline. So then, given that, can you read what you write? Can you avoid situations where you create an account only to be told you don't have an account? And in fact, even in something like Raft, which is a strongly consistent consensus protocol, things always ahead or behind each other, because that's the way asynchronous works, right? That's the way computers work. That's the way networks work. You will never have a perfectly synchronized system. It's not the way the universe works, sadly. So even in Raft, some logs will be ahead or behind each other, and that's normal behavior. So let's see what happens with Raft again. So I need to log in to continue my purchase. Oh, actually, I need to make a new username password, account not found. That sucks. But what's even worse is if I did try it a few minutes later, that says login successful if you have a projector that has high enough resolution, by the way. That's not some cunning thing. It does work. And if, in a way, that's even worse, right? That it didn't work, but then I waited for a second and then it did work. Like things should either work or not work, right? This is like a Byzantine fault. This is computers messing with me in the worst possible way, right? Absolutely hate that. Why didn't this work? Why did it work this time? Because of time. Time passed. So what was happening was, down at the Raft level, we did create a count. Some replication was happening. As you can see, I replicated into a majority here, records 10 and 11, and the account was created. But then when I came to log in, what happens is I hit this replica here. You can see that records 10 and 11, my username and password, haven't reached this machine yet, but they will, and they must, because the majority of the cluster has committed them, but they haven't hit here yet. If I wait a moment, then I will get it. So what I can do is I can wrap this in a causal boundary. Effectively, turn my database into something that looks like a variable in your programming language, right? It'd be really weird if you said int I equals 10, and then you said print I, and it said 11, right? Now, computers, trust me, they do work like that under the covers, right? Computers are themselves asynchronous networks under the covers, and the only reason computers seem to work is that we have these magical things called memory barriers. In distributed systems, we don't have memory barriers, but we have other things that can help. One of the things is a causal barrier. In Neo4j, we use the term bookmark because at Neo4j, we're bad at naming things. For example, we're called Neo4j, which is a terrible name. It's a really good Git hash. It's a really terrible name for a product. So we've got these things called bookmarks, and bookmarks tell you the transaction ID of the last transaction that you observed. So you can do this again with causal consistency. So you create a user, it gets committed in a majority, so now we're committed, but we send back the transaction ID where that record was committed. Now, when I come to the read channel, I provide the bookmark as a parameter, and what will happen is I'll be slightly delayed at the replica that receives that request until the record has replicated, as Raft will soon enough do within the next few milliseconds. Then I can safely run the query and the login is successful. So you've got the interesting interplay of two different approaches here. You've got a strongly consistent consensus protocol, which is Raft, and a causal layer on the top that means you never go back in time. Right? So one of the big Achilles heels of distributed systems is that you go back in time so often. If you're going to write this, it's trivial. You grab a bookmark from the transaction ID, and on the read side, you provide the bookmark as a parameter to your begin transaction. So it's trivial to use. You opt in, but it's super easy to use, and you'll never go back in time. So takeaways. Raft, as a non-blocking distributed consensus system, is amazing. It's safe, it's highly performant once you've optimized it, and there are very few places for bugs to hide. Given what you've learned in this 15 minutes, you're in a very good place to be able to go and explore Raft further yourselves. If you wrap Raft in a causal barrier, you get the best of both worlds. You enable Raft to run over a wide area network, but you preserve correctness from the user's point of view. And I think that's very important, right? Users don't like it when they have to refresh their app or press F5 on their website. It gives a really poor user experience. We shouldn't let the details of murky distributed systems thing leak through to the user interface. And you certainly shouldn't be putting thread.sleep 1000 into your code as if that magically fixes distributed systems problems, despite the fact it does appear to magically fix most distributed systems problems. Distributed systems are still hard. They shouldn't be the first thing that you reach for when you're developing a business information system, but they're going to be necessary for some parts of your solution. Look at the things that the Red Hat guys talked about earlier, right? An interesting interplay of a bunch of distributed systems. But we do now have the underlay to be able to make these systems reliable so that we can present them to end users. If any of this has piqued your interest, I would recommend Unmesh Josh's book. It's an excellent starter, very friendly, written in the kind of pattern language. I think the ThoughtWorks folks are here somewhere. Unmesh works for them, so go hit up the ThoughtWorks folks. If you want to come talk to me about graphs, distributed systems, and all sorts of fun, I'll be on the Neo4j stand all day today, and I'll be speaking about graphs and LLMs tomorrow. So thank you very much for paying attention for these 14 minutes. I hope you have a spectacular day. Thank you all.
Dr. Jim Weber, thank you so much for that. All right, so our next speaker has 23 years of experience in the enterprise software development space. His focus is mainly on the server-side platform and application stacks. He's worked on cloud computing and related workloads at Google, VMware, Salesforce, where he is currently focusing on implementing gen and traditional AIs for verticals in the CRM space. Please help me welcome Rajdeep Dua. Ladies and gentlemen, it'll be just a few moments while we figure out some technical difficulties. Thank you for your patience.
What happened? Huh? I have a
Just a reminder that we will be doing a refreshments and coffee break after today's keynotes. Before we're launching into the day's sessions, we'll have 5 different sessions in the halls: the main hall, hall A, B, C, and SD halls. Please turn to page 6 of your guide for listings of all of today's sessions. Thank you. As always, if there are any questions, please touch base with our registration desk out front. They will answer any questions that you might have today. Thank you.
oh, sec-
After coffee and refreshments, all sessions will start promptly at 11 o'clock.
it's good. It's good. Okay. Good morning, everyone. So you cannot get technology right, the first time, and it always happens, be it a keynote or a normal presentation. So my name is Rajdeep Dua, and I'm handling a couple of engineering teams at Salesforce. I spoke at a keynote here a few years ago, and things have changed quite a bit. So today we are going to talk about generative AI in enterprises. We had some very interesting keynotes, one on from OpenShift and one from Neo4j. So this presentation is not like deep in the woods in the code. We are going to step back and look at the overall landscape and where Gen AI is going in general, and how are enterprises adapting? What are the challenges we are looking at? So all of us are quite familiar with the rise of Gen AI, right? I don't need to give gyan here on where it is going, but the important thing to note is that we are looking at an annual growth rate of 42%. And this AI, Gen AI market is going to be $1.3 trillion market in a few years by 2032. This means that a lot of investment is going into infrastructure, platform, and applications around Gen AI. And I'm talking about both B2C and B2B. This also means that it's going to add a lot of productivity enhancements, especially in the enterprise workloads. This means we are going to look at a productivity improvement of about 3.3 points, right? But all of us have heard about shadow IT, right? Now we are looking at shadow AI. Developers, they want to perform and they want to be productive. So they are not waiting for the traditional IT department to roll out Gen AI tools. They are going to get their own tools by circumventing IT, right? And this means that a lot of CIOs are worried about the security loopholes and privacy concerns and their proprietary data getting leaked. So what are the key trends? According to the Forrester prediction, while OpenAI and some of the models from Bard and Gemini, they have been useful and they have been popular, but the future looks open source, right? Open source is going so fast that everybody is worried. But it means it's good news for us developers. It means that we have a chance to look at these open source and see how we can use them without having to pay the top dollars to companies like OpenAI. This also means that we have to invest in our own platforms to host these models. And 40% of the enterprises are already looking at these models, how they can help improve their productivity. But the problem is, how do you remain compliant? Compliant with some of the policies which are getting rolled out within the enterprise and also at the government level. We look at some of the AI governance models which EU is rolling out. 60% of these workers are going to use Gen AI whether you like it or you don't like it. I think we love it, but our IT department does not like it. What does it mean? As I said, there's a huge amount of investment going into Gen AI. This also means that at some point in time, we have to figure out the ROI. How are we going to find the product market fit, right? So much VC investment is going into startups. It means that at some point in time, these startups have to start making money. So time will come when people will start asking, hey, how do you monetize all these boutique startup use cases, right? They have to merge with the enterprise use cases. The cost of inference is still very high. If you look at traditional models, whether they are like normal machine learning models or deep learning models, they are still much faster and cheaper to get the prediction out from as compared to a LLM, right? How do you optimize? Then prompt tuning has become very popular. There's a whole new profession of prompt engineers, but people have realized there are limitations, right? Which means that we have to move towards fine tuning. And we saw one simple demo of fine tuning, but the challenge is fine tuning is not easy, right? And I have seen use cases where after fine tuning, the model was performing even worse than without fine tuning. So, how do you go there? Then the rise of RAG, right? We talk about retrieval augmented generation. A lot of enterprises have data logged in into their databases and their own data lakes. They want to use that data, but they don't want to send raw data to large language models, which are traditionally not multi-tenant. So how do you circumvent these use cases? And then while the large language models are popular, they are easy to use, easy to adopt, but the future might be smaller models and specialist models, right? Which will make it easier to deploy, to manage, to update. And models themselves are becoming multi-model. They started with text-only model. Now we are looking at the same model which can intake an image, a video, a speech file, and also predict the same output, right? And you can overlay all these kind of various inputs together into a same prediction. And last but not the least, the AI governance. Government at some point in time is going to come in and start looking at high risk applications and how do we reduce this risk. Which industries are early adopters? From the graph, you can easily see that technology, media, and telecom is at the forefront, along with financial services. So at Salesforce, we have a bunch of financial services products, but there are a lot of challenges which remain. Banks and financial institutions, they are regulated industries, right? Which means that this data cannot go out. If it goes out, they want to host their own models, or even if they don't want to host their own models, they want to make sure there is a trust boundary around it. There is enough obfuscation happening before you can even get the data out. And within these verticals, which functions are early adopters? Marketing and sales are definitely the early adopters. That is where I think we see a lot of momentum, especially around how do you generate sales summaries? How do you convert these sales calls, which are speech only, into text and analyze and figure out the key trends, whether it is sentiment, where your opportunity is going, whether your lead is going to close or not, the use cases like opportunity scoring, lead scoring, and so on. While they were being solved using traditional AI, people are figuring out some of the generative models could be leveraged, especially around summarization. So this is a typical life cycle of a Gen AI application. So this is slightly different from the life cycle of a normal software application. The difference is in the middle, that red boxes which you see. So defining a use case is an important. It's like one of any software development life cycle, right? First, you need to figure out, does this use case even need generative AI to be used, right? So I have seen people saying that, hey, can I use it for classification, recommendation, regression? The answer is no, right? Gen AI, they are specialist models. Don't use them like a hammer on every nail. So make sure that you have the right use case for which Gen AI is the right fit. Once you have the use case and the process figured out, what kind of model you want to use, right? What are the trust boundaries? Is it a high risk application or medium risk application? Is it a regulated industry or not a regulated industry? That is where the choice of model becomes very important. Especially, I'll give you an example. We are rolling out few Gen AI applications for banks, and as we go into EU, we have to figure out those LLM models have to be, they are hosted in EU. So think about all those things, right? And if you're choosing a open source model, especially from Hugging Face or any other hosting solution, you are not going to serve it in production from Hugging Face. You have to figure out the whole serving infrastructure. There was a pitch from OpenShift and Red Hat guys, but it's a non-trivial problem to solve. And once you've figured out the model, then three elements come into picture. Is prompt engineering good enough, or do you need fine tuning? Don't jump the gun on fine tuning, but evaluate it. So evaluation metrics, we have specialist evaluation metrics for Gen AI models like Rogue and Blue, and there are new models coming out, but it's not easy. So the key is for LLM evaluation, make sure the PMs are providing you the right utterances against which you are going to test your output. And make sure you align with the human feedback. This means that even during development, you have to keep your PMs involved. Once you have everything laid out, and these models and the predictions they are emitting, they are not going to remain in isolation on a screen, right? It has to interweave with rest of the workflow, especially in like CRM use cases. They have to be there in the summarization page or in some dashboard, or we have a new kind of applications which are like conversational applications, right? The bots have been around for a very long time, but the challenge with bots was that they are like all slot based. So now we are moving from slot based bots which needed a lot of custom training on intents. Now we are moving to LLM based bots which are much smarter. So we have this whole rise of co-pilots. I'll talk about it in a second. So make sure you have the output from LLM weaved very nicely into your whole process. So Gen AI in financial sector is a very interesting use case. While they are the early adopters, their focus is not on productivity improvement for revenue growth. Their focus is productivity improvement for cost reduction. Because for them, IT is a cost center. It's not a revenue generating function. But if you look at healthcare, the scenario is totally different. It's a very complicated regulated industry, but lot of scope. If you look at drug discovery, you look at risk mitigation, if you look at resource allocation, especially in fact, we have a healthcare product where we are looking at scheduling of doctor's appointment, scheduling of clinical visits, especially if you're doing clinical trials. It's an industry in itself. Choosing the site to do your drug testing. So all those things can be optimized in a much, much better manner with Gen AI. And plus, there are specialist models being built just for these use cases like diffusion models, especially for image reconstruction, image generation, and so on. See, a lot of these models are today being used or will get used in these MRI and CT scan machines, right? And to fine tune those models, there are not enough input data available. That is where Gen AI will be used to generate that synthetic data. Especially all these models, if you look at diffusion models, GANs, and variational autoencoders, all three will be used for generation of synthetic CT scan images. And then for clinical decision support, we have transformer models, which can do image to text to text, and so on. For doctors to do diagnosis, summarizing the whole input is very important. And that is where these evidence-based clinical models come into picture. So few other things I wanted to touch upon. As I said, a lot of data is in the enterprise databases and data lakes. People are not going to expose that data to large language models. That is where vector search, embedding search comes into picture. So you basically, the use case is, so you convert all your textual data into chunks, convert it into embeddings, store it in vector databases. So you search, when a query comes, you search for the right chunk and then combine that chunk with the prompt and then send it to the LLM. That is how you get the summarization. But the challenge is traditional vector search or traditional RAG is not good enough. The search queries are complicated. So that is why we have this concept of advanced RAG. So these are early stages, right? Query rewriting, post-retrieval processing, augmentation of the search responses. All these things are, I think we can spend a couple of hours just on this topic. So I'm just trying to say that this is how enterprises are overcoming the fact that they don't want to send their proprietary data to large language models. So I talked about conversational AI. The rise of copilots is important. Why it is important? We are moving from point and click UI to conversational AI. And LLMs again play an important role. Uh, and just imagine LLM combined with vector search and RAG, it's a deadly combination for any enterprise. But people are still figuring out how do you basically get it out at scale? How you can replace all your BPO and backend processes and all those people with automated agents. They can be done for the first layer, but eventually they will go down into tech to tier 2 support, tier 3 support. So last thing I'm going to talk about, we have very few time, very small amount of time left. AI governance is a very important topic. We could have a 1 hour lecture just on AI governance. Governments are not going to sit quietly. If you look at EU, they have already come out with this pyramid and they are going to classify the AI applications into high risk, unacceptable risk, and limited risk applications. They don't worry about minimal risk applications, but applications which are going to decide who is going to get that next job. Applications which are going to decide which patient gets prioritized. They are going to review all of them. For high-risk applications, actually, they have come up with a workflow. And believe me, each of these applications have to be registered with EU central body and they will review. And if they find there is a bias, they are going to come back and make sure that you change that application. With this, we are coming to the end of the talk. To summarize, GenAI is for real, but these are early days of adoption. Lot of challenges in front of us. AI governance is a big issue. So LLMs are inherently not multi-tenant. So make sure you guard your data, obfuscate it before it goes to a large language model. With this, come to an end of this talk. Again, we'll be out there. You can reach out to us and really excited to be here. Thanks again for attending the keynote. Thank you.
Thank you, Mr. Duo, for that. Please refer to page 2 of your guides for a map of the campus so that way you may see where your next session is. Please note that all sessions start at 11 o'clock. Thank you so much.
What's that? Oh, there we go. Hello, test 1 2, test 1 2, test 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 test. Looks sounds good.